Hello everyone, welcome back. This video is in continuation to part 9 of IUPAC nomenclature, where we have discussed some examples on IUPAC nomenclature, and today we are going to discuss some more, so don't miss it. Here are some important features of IUPAC nomenclature. You can go through it one by one, but have to remember them while writing the nomenclature. Step 1, Step 2, 3, 4, 5, 6, 7, 8 and 9. In the last video, part 9, we have discussed till example 6, and today we will start with example 7 and continue till example 20. Write the IUPAC name of the following compound. Easy, right? The compound has 2 carboxylic acid groups and 6 carbon in the chain. So the name is hexane dioic acid, 1,6-dioic acid, or you can also write it as hexane dioic acid. Both are correct. Coming to example 8, write the IUPAC name of the following compound. This is also easy. Don't you think so? The substituents in the compounds are chloro, bromo and nitro, and all these groups always act as substituent and has prefix name. Refer to the priority table. Halides get preference over nitro group. So the numbering should start from left hand side, keeping in mind that the alphabetical order the name of the compound, guess what it will be? It is 3 bromo, 2 chloro, 5 nitro, hexane. Now example 9. Write the IUPAC name of the following compound. See, there are 2 functional groups, alcohol and aldehyde. Who gets preference? Again, the priority table and the trick. Come, sit, eat, apple, almond, naka, tea, and announce, all applaud. So, naka, nitride, aldehyde, ketone and alcohol. Aldehyde gets preference over alcohol, and the numbering should obviously be like this. So aldehyde will be the principal functional group and we have to use the suffix name, whereas alcohol and methyl groups will act as substituents and we have to use their prefix name. So the name of the compound is 3-hydroxy 2-methyl propanal, following the alphabetical order. H comes before M, and so 3-hydroxy 2-methyl and not 2-methyl 3-hydroxy. Please notice. Next, write the IUPAC name of the following compound. Again, 2 functional groups, aldehyde and carboxylic acid. Refer priority table and trick. Carboxylic acid gets preference over aldehyde. So the numbering goes like this. And the name of the compound is 3-methyl 4-oxo butanoic acid, where methyl came before oxo in the prefix name because of alphabetical order, and the prefix name for aldehyde is oxo. The suffix name for carboxylic acid, oic acid, came after the parent name. Next example. Write the IUPAC name of the following compound. I hope this is easy for you. Do it yourself. By this time we have done enough examples. So pause the video, solve it, and then check with the video your answer is correct or not. Here also there are two functional groups, ketone and carboxylic acid. Remember the priority table and trick. So carboxylic acid gets preference over ketone, and so the numbering goes like this, and the name of the compound is 2-methyl-5-oxohexanoic acid, obeying the alphabetical order in naming the prefix name. Next again is a similar example. Write the IUPAC name of the compound. Look at the compound. There are functional groups, three functional groups: aldehyde, ketone, and nitride. Follow the priority table and trick. Who gets preference? Nitride, right? And so the numbering of the compound goes like this. And the name of the compound is 2-methyl-5,7-dioxo-heptane nitride. Coming to example 13. Write the IUPAC name of the following compound. The compound has a double bond and triple bond. Who gets preference? Ene gets preference over ine according to the periodic table, and according to the priority table. And note that both ene and ine has no prefix name. It has only suffix name. And so the name will always come after the parent name. And so the name of the compound is hex 1-ene 5-ine. Example 14. Write the IUPAC name of the following compound, and the options are cyclohexane carboxylic acid, 2 cyclohexanoic acid, 3 heptanoic acid, and 4 hexane carboxylic acid. First look at the compound. The compound has a cyclohexane ring and a carboxylic acid group. So the option 3 and 4 are wrong, since they don't have the prefix name cyclo. Now which is the correct option, 1 or 3? The second option indicates that cyclohexanoic acid, this name indicates that there are 6 carbons, but the compound has 7 carbons. So the option 2 is also wrong. So the correct option is 1. Let's cross verify the name. The name cyclohexane carboxylic acid indicates that there is a cyclohexane ring and a carboxylic acid group at one position, which is not indicated in the name as there is only one functional group. Coming to example 15. Now, in this example, we have converted the earlier carboxylic acid to ester. It is a methyl ester of the earlier carboxylic acid, cyclohexane carboxylic acid. Ester has a suffix name 8. Refer to the table. Therefore, the name of the ester is methyl cyclohexane carboxylate. Just like ethanoic acid, when converted to methyl ester, we name it methyl ethanoate. Similarly, this ester, the methyl ester of cyclohexane carboxylic acid, will be named as methyl cyclohexane carboxylate. 8 means ester. 8 means ester. Coming to example 16. Write the IUPAC name of the following compound. Now, ester in the presence of carboxylic acid is named differently. The priority table says that esters are less priority group than carboxylic acid, and so the ester name should come in the prefix. The numbering of the compound goes like this, and the name of the compound is 6-methoxy 6-oxo-heptanoic acid. 6-methoxy is because of this methoxy group at the 6th position, and 6-oxo is because of the carbonyl group at the 6th position. This is how we name an ester when the ester name comes in the prefix. Coming to example 17. Write the IUPAC name of the following compounds. The first compound is similar to example 7, and the name of the compound is heptane dioic acid. Now see the twist. The moment we put a third carboxylate group, our numbering will start not from this carbon but from this carbon. 1, 2, 3, 4, 5, leaving this carbon. This is to give equal importance to all carboxylic acid groups. Now, the name of the compound will be pentane 1,3,5 tricarboxylic acid, where all the carboxylic acid groups get equal importance. Interesting, isn't it? Now coming to example 18. We have converted the compound in example 7 into a dimethyl ester. So, the name of the compound, guess what? It will be definitely dimethyl hexane dioate. See, this is the acid. So, if the acid name is hexane dioic acid, so its corresponding methyl ester will be named as dimethyl hexane dioate. 8 means ester, and there are 2 ester groups, and so it is dioate. And there are 2 methyl groups here in the ester, and so dimethyl hexane dioate. Coming to example 19. Write the IUPAC name of the compound given below. The compound is an the compound is an ether. Ethers fall under the table where the functional groups always act as a substituent and has a prefix name. So, the prefix name of ether is alkoxy. Here it will be methoxy, and so the name of the compound is methoxycyclopentane. Coming to the last example 20. Write the IUPAC name of the following compound. So what we have done? We have introduced an aldehyde group adjacent to the methoxy group in example 19. So because of that, will the name of the compound be 2-methoxycyclopentanal? Methoxy and cyclopentanal indicates that the compound has 6 carbons, but actually the compound has 7 carbons. So the name of the compound will be 2-methoxycyclopentane carbaldehyde, just as cyclohexane carboxylic acid and not cyclohexanoic acid in example 14. That's all for today. If you like my video, please subscribe, like, share and comment. Please comment because your comments are very valuable to me. Before we end, I would like to share a thought. A river never goes reverse. A river never goes reverse. So, try to live like a river. Forget your past and focus on your future. Thank you and bye-bye.